Video. Okay, so let's get started. There's a lot of stuff we want to talk about today, okay? All right, so I hope you all had a really good break, and we're going to get back into the swing of things. Let me explain some things before you ask any questions, okay? So we have quite a few things going on, okay? The first one is you picked up 2 copies when you came in, okay? They are, one of them's review and the other one is kind of an extension talking about simplifying radicals. Today we're going to talk about dividing with radicals and go through that process, okay? We're also going to apply the ideas about circumcenter and in-center that we talked about before we left. Before we get into that, here's a couple of reminders. We have constructions where we did the constructions for circumcenter and in-center that will be due tomorrow, okay? Many people are already turning them in. They look like this, and you did quite a few constructions on that back page, okay? So you need to, after I quit talking about new stuff, make sure that you finish this, because you could have just not done the last one or something. You may have a little bit left. Finish it up and turn it in by tomorrow, okay? So that's first. All right, the other thing is we have our project that is due, okay? Everybody was here before the break, I think, that talked about the project. Okay, so on the project, the first check of the project is due this Wednesday, okay? That date is December 4th. It is basically in this first little paragraph that describes what's due that first check, okay? So remember that if you turn it in late, you don't get the 10 points. And this is, remember, I'm in a grade with the rubric on the back, okay? So just to remind you what's due for the project. Okay, the type theme is due. You have to say what your theme is, and your pictures have to connect to your theme. You should have chosen at least 5 photos by now, okay? You don't have to give me the photos Wednesday, but you're supposed to give, you should also include a list of vocabulary words you will include in your project with their chapter and section. This is typed, okay? So you're basically going to walk into class that day, have it typed up and say, here's my first piece, okay? And so then I'm going to check those and give you your 10 points, okay? So if you've done everything. If you didn't do everything, then I'll dock some points off of that, so make sure you've done everything. So remember I told you you're doing 16 words, but you have to have 10 of them already decided by Wednesday. So hopefully you've been working on your project. I don't need to see the pictures, but I should see 10 words. And then I also told you when I handed this out to go ahead and turn in the description for those 10 words. So when you turn it in, you're going to have 10, you're going to have your theme, your name obviously, your theme, and then you're going to have your 10 words, the section numbers for those 10 words, and then you're going to do your description for each of those 10 words that describe the pictures that you're using. So basically you should have 10 pictures already, okay? So now, just to remind you about the description in your paper that describes everything. An example is this photo of a border shows perpendicular lines. Since the border is in the classroom, it ties to my theme, I love being a teacher, okay? So once again, you're writing those descriptions down and they should explain how the thing you're describing connects to the project or your theme. Okay, so I also want to remind you this page of your project was not something you're turning in. This is for me, okay? You should have all this stuff typed up. So on your first turn in, this first check that I'm looking at, your first 10, you're probably just going to be adding to that when you turn in your final project, okay? So the actual written explanation is not due with this on Wednesday, just those things I told you about. Okay, Real quick, question, sir.
Can you say it was like all due on Wednesday just to like clear it up? Because I'm confused, because you said.
Okay, again, if you didn't get it, this very first paragraph on your page tells you exactly what to do. The only thing that I added was that when you list your words, you're adding the sections and the theme. Not the theme, sorry, your description.
So I need 10 descriptions.
You need 10 words, their sections, their descriptions, and then the title of your theme.
That's all due on Wednesday?
That's what's due Wednesday.
So I have to have 10 pictures basically by Wednesday?
Basically, I just don't see them yet. You're typing in, so I'm seeing your progress. That make sense?
Yes.
Okay. So hopefully, I don't want you all cramming this in at the last minute. I'm trying to coax you along, okay? Does everybody understand? Okay, so that's due Wednesday. Okay, so the actual project is due December 12th. Okay, again, that's all on this paper, okay? And remember that when you type it up, you'll put your typed written explanation on the back of your poster and all that good stuff, okay? All right, so that's enough about that. So we've got the constructions assignment that many of you've turned in. You've got your project check Wednesday. And what else? Am I forgetting anything? Nothing.
What are these two?
Okay, so you got 2 new worksheets today. These will both be due Wednesday of this week, and we're gonna spend most of the rest of this class talking about them, okay? And adding to what we know there. Everybody comfortable? Okay, so that's kind of what's going on in this class. I am gonna give you back your quizzes either today or tomorrow, not sure when, but I will allow you to retake those 2 quizzes on Thursday or Friday morning of this week. Okay, so if you have one or the other that you need to work on. They were very different pieces of work because some people are really good at vocabulary but really bad at doing radicals. Some people can do radicals but they can't remember words. So 2 different pieces of work. You may retake those up to an 80 Thursday or Friday of this week. So you'll either get those back today or tomorrow, okay? All right, now does anybody have any other questions before we get started? Yes?
Me?
Mm-hmm.
For the project, do the words have to come from each chapter?
Remember that there was a guideline that you had to have at least 2 words from every chapter, and then after that you could choose wherever for the other 6.
Like 2 words from chapter 2, or like
Right.
not 2 from like 2.1.
Right. Right, yes.
Do we have to have like one from every chapter?
You have to have 2 words from every chapter.
Yeah, but like on a rough draft.
I don't really care on that. In the end, you should have the right amount. Does that make sense? So I would try to go ahead and sprinkle those out and then do the others, but yes.
For the quizzes, would they be like different quizzes? Than
I might scramble them, but have the same questions. So like the words I would scramble and have the same questions. The radical stuff, I'd probably change the numbers. Okay, does that make sense?
Mm-hmm.
Okay, so with that said, let's get started. Today we're gonna be working with your radicals, and we're also going to talk a little bit about circumcenter and in-center. So let's go to this circumcenter and in-center paper first. And I want you to notice first about this paper. The numbers are all out of order, okay? So the first thing is I'm looking at number 17 on the front of the page, okay? There's also another number 17 on the back of the page. I'm on the front, okay? So just noticing that, okay? So as we talked about the circumcenter and the in-center, what is the circumcenter? A point that's equidistant from all the vertices in the triangle. Tell me more.
It's the point that's formed.
What is it the concurrency point of?
Angle bisectors.
All the
Angle bisectors.
the perpendicular bisectors, right? All right, so we've slept since we've done this, right? So the circumcenter was the intersection of all the perpendicular bisectors of a triangle, right?
Yes.
And then, Sam mentioned that it was the same distance from all the vertices of the triangle. The reason for that was that if a point lies on the perpendicular bisector, it's equidistant from the endpoints of that bisector, right? Of that segment. Does that make sense? Y'all remembering that now? So you're actually applying that idea when you do number 17. Take a look at number 17 and just try the problem. Don't shout it out, just try the problem. Did that wrong. Okay, so now, I've given you a couple of minutes. I want to, ask you this, okay? Before we all went on break, we were all really, really tired, and some of us were getting to where we didn't want to do anything. Is that right? Okay?
Still like that.
You're still like that? Okay, well, I'm trying to encourage you to kind of take a deep breath and really pump it up for these last 3 weeks, because this is where things really, really count, right? Because we're finishing up the first semester of this course, okay? So this is where your grades will go in and really, really count, okay? So you're gonna wanna really get with it, and if you kind of drop the ball a little bit before the break, this is the time to give yourself a new push, okay? And just finish strong for this break, okay? So if you just zoned out and said, I'm not doing that, I'll just write it down, okay? Because you're tired, okay? I get it. But you're gonna have to push yourself a little bit, okay? So it's time to really make sure you get your grades up and that kind of thing, okay? So just keeping that in mind as to where we are in the semester, okay? So if you'll take a look at this number 17, you have the perpendicular bisectors in the picture. They are not all labeled, but you have right angles. And these marks are here, so that's showing you perpendicular bisectors. They meet at P, the point, and that point is actually a what? Circumcision. Okay, we want PX. How much is it? 9. It's 9, right? Because we know after doing that construction, you should be thinking this and this. This is the circle would go right around there. That would be the radius, right? Does that make sense? So the answer is 9. Everybody comfortable?
Mm-hmm.
Okay. Go on. Let's go on and take a look at number 4 below. Okay, now we're switching gears. This is the angle bisectors, different thing. Okay, angle bisectors of triangle XYZ meet at point P. Find PM. What is point P called?
The instant.
The end center. Okay, so just to review, the end center is the intersection of all of the angle bisectors. And we know that the end center is located where?
And the insector.
At the intersection of the angle bisectors.
At the intersection. Okay, so what's that special theorem about a point on the angle bisector?
The incident theory.
Okay, I don't know if it's called that or not, but what happens?
Yeah,
That's what you said.
It
but
is
it
the-
means it's equidistant.
Is that what you said?
Yeah, it means it's equidistant from the sides of the triangle.
It's equidistance from the sides of the triangle, right? So if you think about one angle, this distance is the same if it's on the angle bisector. That was the theorem, right? The initial theorem, that was about an angle bisector. Then we looked at it for the in-center. Is it called the in-center theorem?
Yeah.
It says that all the angle bisectors are equidistant from the side, which tells us that that piece is the same and our answer is 9. Is everybody comfortable with that? Y'all remember that idea?
Yeah.
Okay, you'll be using that throughout this work that you're doing, okay? Now, we're gonna flip the page over and look at one on the back, because there is one piece here we have not discussed. And I'm looking at problem 17 on the back. If you'll take a moment and just look at it. Okay, so looking at number 17, the perpendicular bisectors meet at point Q. So point Q is a, what's it called?
It's a
Circumcenter, right? All right, I want QN. QN, I want to know this one.
Mhm.
It's a little bit harder on this because we have to actually figure it out, right? It's not just already labeled. In other words, QN is the same as what other pieces?
PQ and QM.
Okay, so we know that these are all the same because this is a circumcision, right? What else do we know? I don't know any measures, so I gotta figure it out.
We know that MP is 48, and that's it.
We know
So this is 48 also?
We know that.
No.
We don't know that.
PM.
PM is 48, okay.
Because
So how much is this piece?
24.
How do you know that?
Because it's a perpendicular bisector.
Because it's a perpendicular bisector. It's
Then
not
you just
marked,
use
but we know it, right? Okay, and then you do what?
Pythagorean theorem.
Do the Pythagorean theorem. So you're dealing with this little right triangle and the Pythagorean theorem?
Mhm.
So you're gonna go 7 squared plus 24 squared equals QM squared, right? And solve it. Solve it. Everybody solve it.
It's 25.
It's 25.
Okay, so this becomes 625. QM is 25, okay? And then we want QN, which is equal to it, so QN is 25. Does that make sense? Does everybody follow that? You're gonna see the Pythagorean theorem kinda in a few of these problems. It's not all over the place, but you'll see it 4 or 5 times. So just be ready, cause you got lots of right triangles in there, okay? So you're gonna finish up that worksheet, and now we're gonna take a moment and we're gonna go on and we're gonna talk about radicals today, okay? So, grabbing your second handout that you got, we're gonna go through some of these. Today we're dividing radicals. This is the final piece of all the simplifying radical stuff that will set us up to be able to operate with them next semester, okay? So we're gonna start with, I'm gonna do the evens on the first page just to get you in good shape and comfortable, okay? So if you take a look at number 2, square root of 8 over square root of 100, okay? You need to understand that when you have 2 radicals in a fraction and they're both under the square root, you can think about this like, this is the square root of 8 over 100, if you want to, but in this case, I probably wouldn't, because we should notice this right off the bat, right? What does that equal? 10. So you could think like this and reduce it and then deal with it, okay? But I believe that I would just do that 10 on the denominator, okay? And then I just have to break down the square root of 8. 2 square root of 2. So I'll put an extra step in there. That's 4 times 2, which is 2 root 2 over 10. Everybody comfortable so far?
It's not just 2/10 root 2 or 1/5 root 2.
We're gonna reduce it. You do need to reduce it, so this would be 1/5. So your answer is the square root of 2 over 5. Okay? Now let's just look at that as if you didn't think about this being 10. If you would have done this, another option, 4 over 50, 2 over 25, you would wind up with that. At that point, this is 5, right? And you can see that this is the square root of 2 over the square root of 25. I'm being very lengthy with the steps so that you can see how the process works. So this is the same thing. Does that make sense? Everybody comfortable? So you could have gone either route to get to your answer, okay? Questions? All right, let's do another one. This one,
Which one? 4 is it?
4, we're gonna go through the evens on the front. Okay, so I'll let y'all help me. Do we want to figure out dividing this, or do we wanna do the square root of 4?
This is square root of 4.
Okay, so y'all do that method, okay? Go ahead and try it. Square root of 4 is 2, and write down your steps, and see if you can get the right answer. I'll give you a second. So once you've done the 4, and you've gotten 2 times 2, we think about the numerator as,
3 square root of 5 times 4.
okay, so it's 4 times 5, so take out a 2, right?
So that'd be 6 square root of 5.
And put it out here, so 6 square root of 5 over 4. Am I finished?
No, we need to simplify by 2.
So I'm gonna reduce this part that's not under the radical. And this is our answer. So get used to, some of these answers are just big and ugly, okay? That's just normal looking numbers, okay? You're gonna run into normal numbers that are weird like that, okay? So are they weird or are they normal? I don't know. Everybody okay on that one, okay? So when you get into calculus, you're gonna run into all kinds of weird numbers, and you kinda have to recognize some things. Real quick, I'll show you this number 12. This is real common in calculus to see this kind of number, and they leave it like this at that level. But you also can see another form of this number, and you need to be able to recognize both forms so you know what you have when you're doing it, okay? So the purpose of this is to make sure you know forms of numbers and you recognize that they're the same thing and that kind of thing. Okay, so we have not done one like this, okay? So 1 over square root of 3. Generally at this level in geometry, we do not leave radicals in the denominator. You probably did this in Algebra 1, maybe? Do you know what to do to it?
Yes, that's multiply it.
Multiply it out.
Denominator by the square root of 3.
You multiply the denominator by the square root of 3, and the purpose is to remove the square root from the denominator, right? Okay, but if I multiply it by square root of 3, I have to write it in a way that I don't change the value of my fraction. So I multiply by square root of 3 over square root of 3. Is this familiar?
Yeah.
You have done this, okay? So you'll do this kind of work next semester quite a bit when we're dealing with area and volume and all that kind of stuff, okay? So, we're gonna go square root of 3 times square root of 3 is 3. And that was the whole point of doing what we just did, is to remove the radical, okay? And then you multiply 1 times square root of 3, and that's just square root of 3. So this is the square root of 3 over 3, okay?
So this is square root of 1.
No,
No.
you
Oh,
can't
yeah.
reduce that number with that, because one's in the radical and one's not. Does that make sense?
Yeah.
All right, is everybody with me? Okay, so you're gonna see stuff like the tangent of this number quite a bit when you get to pre-calculus. Or you might see tangent of this number. They are the same, okay? So you'll get to a point where you're allowed to leave that multiplying out again, but that's not yet, okay? So let's go back up. Let's look at number 10 and number 8.
We didn't do 6 here.
Or 6. We'll go backwards. Let's do number 10 next. Everybody do number 10. Okay, so your first thing should be, I can reduce something, right? Everybody want to reduce something, okay? Make sure you're trying it, that you are working your brain, okay? So we are actually doing, let's see how I can write this. It's actually 1/3 times a big square root of 15 over 10. You do not have to write that down, okay? That's the thought process that's going on, okay? The 3 is sitting there on the bottom while you reduce, under the radical, okay? So then you're going 5 into 15 is 3, and 5 in, okay, so this is 3, and this is 2, okay? Now, I don't know that that helped a lot, but the numbers are smaller at least, okay? So at this point, I have the square root of 3 over 3 square root 2. Does that make sense? This will spare us from having to go root 10 over root 10 and deal with 150, which is a large number, okay? Everybody okay on the reducing? All right, so I've gotten it to a point where I still have a radical in the denominator, so I need to remove the radical from the denominator, okay? So when you multiply here, you're only gonna multiply by the root 2. You're not gonna multiply by the 3. If you do, you'll still get it, you'll just have to reduce it again, okay? But it's only necessary to multiply by root 2 over root 2. Okay? Remember, the purpose of this is to remove the radical. So what is 3 root 2
6.
times root 2?
6.
3 times root 4, which is 2. 3 times 2 is 6. Everybody okay with 6?
Yeah.
Everybody comfortable? So 6. What's on the top?
Square root of 6.
All right, we're done. Does that make sense?
Yeah.
Okay?
Wouldn't it just be easier to multiply it out first?
It's a matter of opinion.
Because it's less steps.
I don't know that it's one way or the other, because you wanted to do like by root 10, is that what you're saying?
Yeah.
I don't
So
know.
it'd be
That
30 over
becomes
150.
30, right? And then this becomes square root of 150.
Yeah. So then you can just do 25 and 6, which is 5 square root of 6.
It's really just a matter of preference, okay? And
That's the
so,
amount of steps.
Is it?
it's still just as long.
I guess it is just as long.
And so but you do get there, okay? So it doesn't matter as long as you get there, okay? Does that make sense?
Yeah.
Okay, so showing you a couple different ways is actually good for you to think about what's happening with the numbers.
I did that way.
You do it in your head.
You did it this way?
You can
No,
take
a
out.
different way. I got it right.
You did it in even another way?
I multiplied by the bottom.
Like root 10 over root 10? That's this way.
No, I multiplied by 3 root 10.
Oh,
I
that's
did it.
much larger. I wouldn't do that because
I
that
did
makes
it.
them a lot, that's probably more painful.
Yeah, it took 1, 2, 3. I took 4 steps.
Oh, okay.
I took 4 steps as well.
Well, and I'm showing you extra steps because I'm trying to get everybody to understand. Go to number 8 and try number 8.
So, can I go to the same next one?
Yeah. You comfortable with what we're doing? Yeah. Oh, these are very similar problems. 8 and 6 are very similar. Go ahead and do both of them. All right, there's number 8. This is a lot easier than the last one, right?
Yeah.
Yes?
Oh, you get the same answer too. That's not
The same answer. Okay, this one, you could just go ahead and make that a 2. And then,
Two.
2 root 3 over 15. That's your answer. And you can leave it like that, because 2 over 15 will not reduce. Everybody comfortable?
Could you,
Okay, so this is where I'm leaving you for today to continue working. Remember the radicals and this worksheet, both the worksheets I gave you today are due Wednesday, okay? So,
Can you write the answers on the board?
tomorrow, okay? I'll try to do that tomorrow.